This class basically we are dealing with remote sensing and GIS application. Actually, this is a state of the art subject nowadays because every one of us using this technology knowingly or unknowingly, and this is consisting of two distinct parts. The first part is remote sensing and second part is GIS application. Because whatever analysis we are doing or the design technology we are using, basically we are using the remote sensing image and data, and based on that we are analyzing all the information and taking various types of decision. Now, if we talk about remote sensing, that means that term itself showing that we are sensing something from remote. So if we say that we are sensing something from remote, that means we are sensing using some sensor which is automated. It is not anymore manual, and this sensing means taking the data from space. That means maybe airborne or maybe non-air. Suppose I am taking a picture from a drone. It is from drone and it is from air, because you see that drone cannot go beyond the air normally. But when I am talking about a satellite, so it is on the free space borne. Again, we have some tower borne. So now, how this technology evolves and comes? It starts, I think, around 1850 or so. It has started from aerial photograph. Now, on the surface of the earth, when we are taking the photograph, we are standing on a particular place, and within the view of the camera lens, we are taking a snap based on the speed of the shutter. That is the normal picture, whatever we are taking. But what is the basic difference when I am taking a picture from the airborne platform, suppose from satellite? What is the difference between the picture you are taking from your normal camera in your mobile or your normal camera system? The difference is that is very important, this difference. The difference is that when I am taking a picture using my camera, I am taking the picture using the camera with some resolution. Each of your camera has some different resolutions, maybe identical, maybe different. What is the resolution? It is called the pixel density. That means number of dot per unit area. That means 1000 dot per unit area, 1 million dot per unit area. That means density of the dots, fluorescent dots of the pixel. But here we have a drawback in my normal camera picture. What is the drawback? The drawback is that I am always measuring in terms of the pixel density. But ever we thought that what is the dimension of a pixel? We never thought about the dimension of a pixel. But for a satellite picture or any remote sensing picture, we have to have a dimension. So you see my university, 430 acres area. Your home, your room has a dimension in terms of length and width. But your normal camera picture does not give you any dimension, only the resolution, which you can change in terms of your Photoshop or any photo editing software. But when I am talking about the remote sensing picture or remote sensing image, there always a dimension is associated. So with whom this dimension is associated? This dimension is associated with the pixel. That means what is the pixel? 10 meter cross 10 meter. Normally we go for a square. Here normal pixel we never go for a square. So 5.8 meter cross 5.8 meter. 23.5 meter cross 23.5 meter. That means when you are fabricating the sensor into a satellite as a transponder, so that is fixed, you cannot change. The span of a satellite, normally we take 10 years because it's mostly operated using the solar energy and battery. So this is the basic difference between a satellite image and a computer image. Now, you see, we have very basic concept about the satellite because we are all from the field of technology, computer science, data science, master in computer applications. So we are all in this technological field. And we know that we have the communication system guided by satellite. Mostly satellite driven communication systems nowadays very useful, and we are extensively using this. Now, this communication satellite is not the remote sensing satellite. Please mind it. These are all different. Then again, there may be a contradiction. You see, those who are even still now observing the cloud, picture of the cloud, content of the cloud, or the cloud modeling on every day in weather prediction in your national TV, Duradarshan. That picture is simulated from your communication satellite, geostationary satellite again. But that is different. But when I am talking about the remote sensing, that means it is a remote sensing satellite. That means the data is taking from the remote sensing satellite. Then obviously your question will come in your mind. Then sir, what is the difference between these two satellites? What is the difference between a remote sensing satellite and a communication satellite? This is first question. I'll give all answer. Don't worry. And you please ask the questions if you have any questions in your mind generated out of my delivery. Please call me and ask me. I'll be very much happy for that. Then you see the one question is coming, that what is the basic difference between a communication satellite and a remote sensing satellite. Now again I'm confusing you. What is the confusion? Now all of your mobile device, smart mobile device, what you are using, that smart mobile device have some GPS, and you see we have some Google Earth. You are tracing, you are tracking the roads, the speed, everything. So how it control? Now if I say that another type of satellite is there to control this, which is called the GPS satellite. Now you see I am talking about the communication satellite. I am talking about the remote sensing satellite. I am talking about the GPS satellite. That means in general we are using these three types of satellites. Some other satellites are there, but broadly we can classify this. Now, the purpose of remote sensing satellite is very clear. But you see that what is the purpose of communication satellite? You see this picture I have drawn. I am very bad in drawing, but I have drawn it anyway. Just to show you, because this picture is not available in any book. So you see that why this communication satellite has come into the picture, maybe for the cloud simulation or for the communication. Why we have gone for that? The basic question is that you see that as we are all technologists, you see that in your school All of you have read this equation. Y equal to wave equation. Y equal to a sine omega t plus theta. So what is the term? This is your amplitude. This is your frequency. And this is your phase. And my communication equation, all sorts of communication is guided by this very simple equation. In your class 9 you have read it, in your school physics. You see that one interesting story. Normally I used to say to all of us, because we are proud of that as a member of resident of Kolkata, that the wireless communication, we know that the inventor of radio communication or transatlantic signal first successfully transmitted and received by Marconi. But nowadays, lot of debates, and then the acceptance has reached that it was done by Sir Jagadish Chandra Bose. Because you see, the story is like that. In 1895, mind it, 1895, Sir Jagadish Bose demonstrated an experiment in the town hall, which is now is the Mahajati Sadan, near your Mahatma Gandhi Metro Railway, that's in the Central Avenue. What he did, that the peoples are inside the hall, and he put some gunpowder and a calling bell. 1895, please mind it. And he make a switch, put the switch on, and he exploded the gunpowder 50 meters away outside the hall, outside the wall of the hall, and rang the calling bell without any wire. And that was the first wireless communication. And using the same waveguide, wave equation, y equal to a sine omega t plus theta. So how he succeeded? What was the technology at that time? Why not that technology is successful in commercialization? You see, now in 2021, we are talking about all these things wireless, everything wireless, e-systems and others. Because you see that normal wave cannot move a long distance. I need some waveguide. You know, in your communication network, you have read it in Faruzan's book, that we need a carrier wave. So what is the carrier? There may be the carrier is amplitude, the carrier may be your frequency, the carrier may be phase. These three may be carrier. So Jagadish Bose used the amplitude as carrier. Jagadish Bose used the amplitude as carrier. And he has modulated this. And he has made a detector. And this Jagadish Bose, Sir Jagadish Bose was the first people to use a semiconductor solid state device. You see, he was died in 1937 only. So now you may have another questions that then why we cannot use this technology in communication? Because you see that when I am talking about the amplitude modulated wave, now we have an ionosphere. So I'm not going into details of that. These stories are very interesting. Jagadish is a major contribution on this elementary research. So that 52 to 50 kilometers, this ionosphere. So we have thundering, we have the movement of clouds. These are all charged particles. These are all charged particles. They are generating, due to the disturbance, they are generating thousands of near harmonics of this amplitude modulated wave. So that's why the data communication, voice communication is okay, because amplitude radio is still there in our villages and others. Even All India Radio has the amplitude modulation still now. We have the All India Radio Center for amplitude modulation. So voice communication is there, but not data communication. So due to this noise, so this subharmonics will be integrated. So this subharmonics will be integrated. And another thing is that this amplitude modulated have the capability of reflected by the ionosphere. You see, if we started from here, it reflected like this. Multiple reflections may be there from the ionosphere. So you see, Sri Lanka Broadcasting Center, Voice of America. So these are this amplitude modulated radio waves. But this could not be used, cannot be used as a data communication because of this noise prone. This is very noise prone. Millions of subsequent or associated harmonics are generated. So now, when I am going for that, so definitely I have to reject that amplitude modulation. Then I have to go for the frequency modulation. Then when I am talking about the frequency, your FM radio is fine. But the problem is that, so this is opaque. That means if I have a frequency modulator, it cannot reflect by the ionosphere. So this ionosphere is not capable of reflecting either frequency modulated wave or phase modulated wave. Then you see, if I got the technology, advancement of the technology, when I am going for it, again another problem is there. So who will reflect my signal? Who will reflect my signal? See? I am putting a reflector. First thing you see, microwave towers are there. Because you see that the communication is that I have the ground wave, which is coming towards the ground because of the curvature of the earth. After some time, it will emerge on the surface. And the sky wave, this is, we have two types of wave, ground wave. This is your ground wave and this is your sky wave. So the sky wave, who will reflect? Your satellite is the reflector. Your satellite is the reflector to reflect the signal. So it is, you see, this signal is coming, signal is being received, attenuation loss of the signal is there, used to repair that and transmit it. So if it is a frequency f1, so definitely it should be f2. There is a difference of delta f between these two. What is the reason? The reason is that you know that interference of the signal. If this distance is more, this distance is more, so you see this angle will be minimum, and you see as if two signals are flowing, there is a 180-degree phase difference. Two signals are moving in 180-degree phase difference. So if two signals are moving in opposite direction with 180-degree phase difference, if the frequency of the signals are identical, then the interference effect will be there and both of the signal will be destroyed. The fringe pattern will be generated. So that's why you will see that in your TV relay centers and others, particularly in rural areas, they used to say, my uplink frequency is this, my downlink frequency is this, with a sufficient band gap. So that's why we are using two different frequencies in satellite. So different types of satellites, we shall just start again from the next day, because the students have requested that a lot of students are not present. Two things are there. So you see, normally we never use the amplitude modulated wave for data communication. But again, for the advancement, in the advancement of the technology, we are using a composite modulation, particularly in mobile communications. Your amplitude and frequency, amplitude and phase are combined together for the proper modulation, and we are using in mobile communication systems. You see now, based on the technology advancement, again it is possible to use the amplitude modulated wave, not solitarily, but in conjunction with frequency or phase modulation for the data communication. Now other questions are there, that three types of satellites. Just I am giving you a glimpse, and then again we shall start from the next class. The first thing is that when I am talking about the communication satellite, I am talking about the communication satellites, it is 36,000 kilometers away from the surface of the earth. It is 36,000 kilometers away from the surface of the earth. And it is geostationary. This is called the orbit is called the geostationary orbit. That means when I am standing here, I am always observing that the satellite is static here. And that's why your disk antenna, rooftop, at your rooftop, all disk antennas are set. It is not fixed at all. That means the relative motion and the rotation is zero. This is your geostationary and 36,000 kilometers away from the surface of the earth. And you see that whatever communication, we are triggering the communication from the ground. We are initiating the communication in terms of a signal. We are initiating the communication in terms of a signal. That means it is active system. This system is called, when I am initiating some signals or the energy, it is the active system. This is called the active system. But let's see the next slide. The remote sensing satellite, the orbit distance is very less compared to the communication satellite. His orbit distance is only 800 to 1500 kilometers. You see, unlike 36,000 kilometers in your communication satellite. It is a low Earth. It's not low actually, it's medium. All of the remote sensing satellite from India, ISRO, is called the IRS. Two series of satellite in India. One is called the IRS series and INSAT series. So when I am talking about the geostationary, it is INSAT, and IRS, Indian remote sensing satellite, all for the remote sensing. Here the interesting feature is that you see that the sensors are here. There may be single sensor, there may be multiple sensors, multispectral sensors, hyperspectral sensor. I'll discuss everything in details subsequently. But these are not active sensors. These are all passive. These are all passive sensors. Why passive? So unlike these communication satellites, you are triggering a signal here. You are triggering an energy. That's why this is active. But here, no energy is being triggered. Here only we are using the source of energy. Who is the source of energy? Sun. Sunlight is coming, entering to the atmosphere, going to the ionosphere, coming to the creature of the surface of the earth, maybe building, maybe road, then it is coming back. Again, it is some distortion on the ionosphere, coming to the sensor. Sensor is taking the data. You see, it's a passive, not direct energy. We are not energizing the sensor. When you are taking a photograph with your flash, when you are taking a photograph with your flash, so first flash is on, light is going to the image, reflected from that image, coming back to your camera, photo is taken. It is the active sensor. But in case of remote sensing satellite, sunlight is coming, falling on the creature of the surface, maybe leaf, maybe vegetation, maybe building, maybe road, maybe sun, maybe sea. Then coming back to the sensor, sensor is taking the data. If cloud coverage is there, extreme cloud coverage is there, on that day you cannot take the data. So all the day, all time data capture is not possible. This is your remote sensing satellite. And the last question is that the GPS satellite. GPS satellite is somewhere here in between. Is 20,000 to 24,000 kilometers away from the surface of the Earth. And it makes an array of 24 satellites, just like this. In 6 orbit, you see, have a 6 orbit and 4 satellites on each orbit. You see, this is the GPS system we are using every day, every time on your mobile. But the signals are absolutely free, non-coded signal. So this is the scenario. We shall study GPS in details. GPS satellite and the communication system in GPS and remote sensing. So our domain of study, half of the domain of the study is the remote sensing and half is geographical information system, which is called the GIS. So that's why the term RS, that means remote sensing, and GIS.